Hello and welcome to Algebra 2 Lesson 62. In this video, we're going to learn about the square root property and completing the square. So I want you to recall that a quadratic equation has a squared term, a squared term, and then no terms of higher degree. So as a generic example, and one that you'll probably see in your textbook, we have ax squared, let me highlight that exponent of 2, plus bx plus c equals 0. So this is a quadratic equation in standard form. So you'll see that the exponents go in descending order. You have the exponent that's 2, then you have the exponent that's 1. And one thing you need to understand here is that for a, b, and c, a is the coefficient of x squared, b is the coefficient of x, and c is the constant, they're allowed to be any real number that you want with one exception. A, the coefficient of x squared, is not allowed to be equal to 0. Because if we plugged in a 0 there, you'd have 0 times x squared. So that term would basically go away. You'd be left with bx plus c equals 0. So without a squared term there, it would no longer be a quadratic equation. And so that's why that's not allowed. We previously learned how to solve a quadratic equation by factoring. And for those of you that took an Algebra 1 course, you've already learned how to solve a quadratic equation by using this process known as completing the square, and then more easily using a process known as the quadratic formula. So basically, we're going to go through that again. Hopefully you did see it in Algebra 1, and this is just a refresher. If you didn't, it's not too hard to pick this up here. So we're going to start out by just going through what to do when it is factorable. So we have 2x squared minus 3x minus 9 equals 0. So what we want to do is we want to factor the left side. So we know how to factor a trinomial into the product of two binomials. Now at this point in Algebra 2, you should have a preferred method for doing this. Either it's reverse FOIL or it's factoring by grouping, whatever you want to do. For myself, I see that this is pretty easy to do with reverse FOIL. You have 2, which is a prime number, times x squared. So I know that's going to factor into 2x and then x. So I know those first two positions. I just need to work out the outer and the inner to sum to this term negative 3x. So the way you do that is you look at negative 9 and you say, well, what are the possible factors of negative 9? Well, it's negative 1 and positive 9, or it's positive 1 and negative 9. The only thing is those would never work out for you. And the reason for that is they're too far apart. If I put a positive 9 here and a negative 1, you'd end up with an outer of 18x and an inner of negative x. Those are too far apart to ever give you a negative 3x in terms of a sum. If I flip the signs around and I did positive 1 and I did negative 9, it's going to be the same thing. It's just too far away. So we can go ahead and eliminate those and say that those are not going to work. Okay, so what would work? Well, in terms of negative 9, you have another possibility. You have positive 3, you have positive 3, and you have negative 3. Now, where would I want to put negative 3? Where would I want to put positive 3? If the result here is a negative 3x, I want the term that's going to be larger in terms of absolute value to be negative. So I would think about the 2x multiplying by the negative 3, and I would think about the 1x multiplying by the positive 3, so that my result, again, when I do the sum, is going to be negative. And we can check this. We do our FOIL. 2x times x is 2x squared. My outer, 2x times negative 3 would be minus 6x. My inner, 3 times x would be plus 3x. And then my last, 3 times negative 3 is negative 9. So if you sum these two now, you would have 2x squared minus 3x minus 9, which is exactly what we started with right here. The main thing here, let me just erase this, is just to understand how we go about solving this by factoring. I want you to realize that this right here inside of parentheses is a factor, and so is this. It's one of the hardest things for students to wrap their head around. This is multiplication here. The quantity 2x plus 3 is multiplied by the quantity x minus 3, and this equals 0. So we use something known as the zero product property. What does that tell us? Well, if you have something like a times b and this equals 0, Well, what are the possibilities? We know when we multiply by 0, we get 0 as a result. So either A is 0, B is 0, or they're both 0. Okay, it's got to be one of those things. So what I can do is I can extend that here and say, well, either 2x plus 3 is equal to 0, or this other factor here, x minus 3 is equal to 0. So when we solve each equation here separately, so I would subtract 3 away from each side of this equation, we would get 2x is equal to negative 3. Then we would divide both sides by 2, and we would get x is equal to negative 3 halves. Then over here, we add 3 to each side of the equation, and we would have x is equal to 3. So you have two solutions here. X equals negative 3 halves, or x equals 3. Let me just kind of notate that up here. We'll say x is equal to negative 3 halves, or x is equal to 3. Using solution set notation, we could put negative 3 halves, comma, 3. Now, if you wanted to, you could pause the video at this point, and you could stop and you could check these. You could plug a negative 3 halves in for each x and verify that you get the same value on both sides of the equation. In this case, it would be 0 equals 0. You could also plug in a 3 and verify that you get 0 equals 0. I'll leave that up to you to do on your own. What I want to do now is talk about what can we do when we can't solve a quadratic equation by factoring. Well, again, we have a few different methods available, and we're going to start out by just talking about something known as the square root property. So here's the square root property. And again, if you took Algebra 1, you'll remember this. It tells us that if x squared is equal to k, then x is equal to the square root of k, or x is equal to the negative square root of k. Remember, we have those two different notations. This is the principal square root, and this is the negative square root. You might say, well, why do you need that? Well, just think about if you had something like x squared is equal to 4. We all know at this point that I could plug in a 2 there and say 2 squared is equal to 4, so that would be a solution. Or I could also plug in a negative 2 there and say negative 2 squared is equal to 4. The real thing is here, when you square something, you lose that information about the sign. Was it positive? Was it negative? Because both of them would work, and you really don't know. So you have to account for both possibilities. And you say x is equal to the principal square root of k, or x is equal to the negative square root of k. So here's another good example. Let's say we saw something like x squared is equal to 9. So x squared is equal to 9. So what we would do is we would take the square root of this side, and then we would say plus or minus. That's a shorthand for saying positive square root or principal square root, or negative square root. You put plus, and then you put a minus sign underneath. And then we'll say the square root of 9. So we all know at this point that this would cancel with this, and we would just have x by itself, and this equals plus or minus the square root of 9, which is 3. Now, don't get fooled here. This is two different solutions. This tells me right here that I have x is equal to positive 3, or x is equal to negative 3. Again, if I plugged in a 3 here and I squared it, I'd get 9. If I plugged in a negative 3 and squared it, I'd also get 9. So we're counting for both of those possibilities with this plus or minus here. All right, so let's take a look at an example that we can use this on. So we have 4x squared plus 2 equals 102. So you might say, whoa, that doesn't look like something I can use the square root property on. If you have a perfect square equal to some number, you can use the square root property immediately. Now, we don't have that here, but we could easily do that if we just subtract 2 away from each side. And then we would have what? We would have 4x squared is equal to 100. Now, you have the option 4 is a perfect square. But typically, it's a little bit easier if you just have a coefficient of 1 here. So let's go ahead and just divide both sides of the equation by 4. And we'll find that x squared is equal to 25. And then if we use our square root property, we could say, take the square root of this side, and then plus or minus the square root of this side. So this would be x is equal to plus or minus 5, right? Square root of 25 is 5. So again, this is two solutions. This is x is equal to 5, or x is equal to negative 5. So we can write negative 5, comma 5 like that. And for this one, let's just stop and check for a second. So if I plugged in a 5 there, what would we get? You'd have 4 times 5 squared is 25. Then plus 2 equals 102. Yeah, 4 times 25 is 100. 100 plus 2 is 102. You'd end up with 102 equals 102. And again, if I plugged in a negative 5, it would be no different. Negative 5 squared is also 25, so it leads to this exact same scenario. Now, let's try without dividing both sides by 4. If we just subtracted 2 away from each side of the equation, we'd have 4x squared is equal to 100. What happens if I take the square root of this side and I go plus or minus the square root of this side? Well, the square root of 4 is 2. The square root of x squared is x, so I'd have 2x is equal to plus or minus the square root of 100, which we might as well just say plus or minus 10. Now, this leads to two different equations. It's 2x is equal to 10, or 2x is equal to negative 10. If you solve these for x, we divide both sides by 2, you're going to get x is equal to 5, or divide both sides by 2 here, you'll get x is equal to negative 5. Again, exact same thing I got there. It's just a little quicker because we divided both sides by 4, okay? And we got x squared by itself. So you pretty much want to do that to save yourself the extra work that we had to do here. All right, let's take a look at another one. So we have 2x squared plus 3 equals negative 19. So again, if I have something squared equal to a number, I can use that square root property. So let me subtract 3 away from each side of the equation. So that'll go away. We'll have 2x squared is equal to negative 19 minus 3 is negative 22. I want x squared by itself. I want 1x squared. So let's divide both sides of the equation by 2. And this will cancel with this. We'll have x squared is equal to negative 11. And then now all I need to do is take the square root of each side. So I'll take the square root of this side, and I'll go plus or minus the square root of this side. So we know this ends up being x, and this is equal to plus or minus the square root of negative 11. Now, we didn't work with negative square roots back in Algebra 1, but here we've already done a lesson where we talked about this. I can say that this is x is equal to the principal square root of negative 11, or x is equal to the negative square root of negative 11. Now, when we think about this, we know that if you have a negative inside, you can pull it out and just say this is I, right? So I can erase that negative, and I can say this is I times the square root of 11. I can erase this negative, and I can say this is negative I times the square root of 11. Now, what if I check this to prove it to you? And I want to do that real fast. So let's just go with this first one. You'd have 2 times x is squared. This whole thing is what x is equal to. So you'd have I times the square root of 11, and this is all squared. Then plus 3 equals negative 19. So you'd have 2 times I squared has a definition of negative 1. But let's just write I squared for right now. I'm just going to put an arrow and say this is negative 1 times the square root of 11 squared is 11. Okay, then plus 3 equals negative 19. Again, I know this is negative 1, so 2 times negative 1 is negative 2. Negative 2 times 11 is negative 22. So essentially what you have here is negative 22 plus 3 equals negative 19. So you end up with negative 19 equals negative 19. So yeah, that works out. So let's erase this real quick. And what would happen if I had a negative I there, if I had a negative there? Well, it wouldn't matter because if I squared that negative, I'd get a positive. It would lead to the exact same scenario where I end up with negative 19 on this side and negative 19 on this side. Again, 2 times, you can think of this as negative 1 squared, which would be 1, times I squared, which is negative 1, times the square root of 11 squared, which is 11, plus 3 equals negative 19. So 2 times 1 is 2, 2 times negative 1 is negative 2, negative 2 times 11 is negative 22, negative 22 plus 3 is negative 19. So again, you get negative 19 equals negative 19. So each of these work as a solution. So the solution said you could put negative I times the square root of 11, comma, I times the square root of 11. Or if you wanted to write this in a more compact format, you could put plus or minus I times the square root of 11. All right, let's take a look at something that's a little bit more challenging. So we have the quantity x plus 12 squared minus 15 equals 181. So can we use our square root property here? Yes, we can. If this guy right here is squared, that's a perfect square. If I took the square root of it, I'd get x plus 12. So all I need to do for this type of problem is add 15 to each side of the equation so that this guy is isolated. So this would cancel itself out, and I would have x plus 12, that quantity squared, is equal to 181 plus 15 is going to be 196. Now, all I need to do now is just take the square root of each side. So I'm going to take the square root of this side, and then I'm going to put plus or minus the square root of this side. So this would cancel with this, and I'm going to be left with this x plus 12. So I'm left with just x plus 12. And this equals plus or minus, the square root of 196 is 14, so 14. So I've got two different scenarios here. I've got x plus 12 is equal to 14, or x plus 12 is equal to negative 14. And you've got to go through both of those because those two different solutions are needed to get a complete answer. So we'll subtract 12 away from each side here. We'll get x is equal to 2. Then or, we'll subtract 12 away from each side here. We'll get x is equal to negative 26. So those are your two solutions. X can be 2 or x can be negative 26. All right, so when we run across something like x squared plus 16x plus 14 equals 0, we can't immediately use our square root property, right? Some of you will see this and you'll say, okay, we'll just subtract 14 away from each side of the equation, take the square root of both sides, and we're done. It's not going to work for that. You need to use a more elaborate process for this, and that process is known as completing the square. And of course, you can use the quadratic formula if you want to, but we're not going to get to that till the next lesson. So for completing the square, we'll just go through that real quick. And this is one of those things you want to write it down and just practice the steps to where they just become second nature for you. It's kind of a tedious process, and a lot of students don't like it, but you want to make sure that you memorize it because once you get to using the quadratic formula, you're not really going to go back to this because of how tedious it is. And then if you need to use it later on, you will have forgotten this process. So the first thing to do is to make sure the squared term has a coefficient of 1. So if we go back up, and I'll kind of jump back and forth, this already has a coefficient of 1, so we're good to go there. The next thing you want to do is you want to move all the variable terms to one side and the constant to the other. So for this one, I could just subtract 14 away from each side of the equation. This would cancel. We would have x squared plus 16x, and then I'll move this kind of down because we're going to need to put something in that place right there. This will be equal to negative 14. So all the variable terms are on one side. These are the variable terms. And the constant is on another side by itself. This is your constant. All right, the next step is the one that's the most confusing. You want to multiply the coefficient of the x term, just the coefficient, by 1/2, then square it. So here's the coefficient for the x to the first power term. It's a 16. If I multiply 16 by 1/2, and then I square it, what am I going to get? 16 times 1/2 is 8. 8 squared is 64. Now you're going to use this in 1 second. I just want to relay a simple trick to remembering this step. When I was in high school, I struggled with remembering this. I didn't practice the steps like I should have. And one day, our teacher said something to us. She said, cut it in half and square it. Cut it in half, meaning multiply by 1/2, and then square the result. You might not remember multiply by 1/2 and square it, but cut it in half is easy to remember. So cut it in half and then square it. Okay, so that's what we've done here. We've cut the number 16 in half by multiplying by 1/2. That gave us 8. And then we squared it to get 64. Now, what do we do with 64? Well, what we do is we add the result, which again, in this case is 64, to both sides of the equation. Now, when we do that, let me just go back up real quick. What's going to happen is the left side of the equation is now a perfect square trinomial. Some of you know what that is. Some of you are like, what is this guy talking about? What is a perfect square trinomial? So as a little side note, let's just show you what that is real fast. We talked about special products and special factoring a lot. If you have something like x squared plus 2xy plus y squared, this is x plus y, that quantity squared. All a perfect square trinomial is something that you could take that looks like this, and you can factor it into a binomial squared. That's all it is. Completing the square just gives you one side of your equation as a perfect square trinomial, which allows you to factor it into a binomial squared, which then allows you to use the square root property. Because I can just take the square root of this guy, and I'll just have what's in parentheses. For this guy right here, this x squared plus 16x plus 64, again, if I think about special factoring, I know that this guy goes here, right? So just x goes there. And then this guy, the square root of that would go here. So all I need to think about is, what is the square root of x squared? That's x. And then plus, what is the square root of 64? That's 8, and that's squared. So I've factored my left side into the quantity x plus 8 squared. Now let me erase this real quick. I'm going to just drag it up. And this is equal to, over here I just need to do a sum. Negative 14 plus 64 is going to give me positive 50. Now let's go back down. And again, factor the left side and solve the equation using the square root property. Okay, solve the equation using the square root property. So we've already factored the left side. So all we need to do is take the square root of this side and then put plus or minus the square root of this side. So this will cancel with this, and we just have x plus 8. And this is equal to plus or minus the square root of 50. Now this is where it gets even more tedious, because the square root of 50 is not a perfect square. So we've got to think about how to simplify that. Let's just start out by saying that this is x plus 8 is equal to the principal square root of 50, or x plus 8 is equal to the negative square root of 50. Let's scroll down a little bit. So the square root of 50 is what? It's the square root of 25 times the square root of 2. Square root of 25 is 5, so it's basically 5 times the square root of 2. This is 5 times the square root of 2. For this guy right here, I might as well say it's negative 5 times the square root of 2. And so what do we have here? You would have x plus 8 is equal to 5 times the square root of 2. We could subtract 8 away from each side of the equation. That would go away. And you'd simply be left with x is equal to 5 times the square root of 2 minus 8. Then or, over here, I would have x plus 8 is equal to negative 5 times the square root of 2. We would subtract 8 away from each side of this equation, and we'd end up with x is equal to negative 5 times the square root of 2 minus 8. Now, if you wanted to write this more compactly, what you could do, you could say that x is equal to negative 8 plus or minus 5 times the square root of 2. So this accounts for 5 times the square root of 2, and it accounts for negative 5 times the square root of 2. All right, so in solution set notation, we'll say negative 8 plus or minus 5 times the square root of 2. Now, you're free to check each solution, right? You've got 2 of them. I've already checked them. I know they work. It'd be good practice for you to do it. In the interest of time and making this video a little bit shorter, I want to just stop right here and move on to the next problem. All right, so let's take a look at another one. So we have 10x squared minus 8x minus 21 equals 5x squared. So the first thing we're going to do, we're going to have this in the format of ax squared plus bx plus c equals 0. So let's just subtract 5x squared away from each side of the equation. That's going to cancel and become 0, and this is equal to 10x squared minus 5x squared is 5x squared. And this is minus 8x minus 21. Again, it equals 0. Now, in this particular case, the coefficient for x squared is not 1. You have a 5 hanging out there. You don't want that, okay? So what you're going to do is you're going to divide both sides of the equation by 5. So I'm going to divide this by 5, this by 5, this by 5, and this by 5. So we know that this would give me x squared minus 8/5 x minus 21/5 is equal to 0 divided by 5 is just 0. Now, the next thing that I want to do, I want to move all my variable terms to one side, all my numbers to the other. So I'm simply going to add 21/5 to both sides of the equation. So you'll have x squared minus 8/5 x is equal to 21/5. Now the next thing I want to do is I want to take this coefficient for the x to the first power variable. I want to cut it in half, meaning multiply by half, and then square it. I'm going to take that result and add it to both sides of the equation. So over here, if I did that, if I had negative 8/5 and I multiply by half, and then I square this, what am I going to get? Well, this would cancel with this and give me a 4. So it would be negative 4/5 squared. The negative square would be positive, so don't worry about that. 4 squared is 16. 5 squared is 25. So what are we going to have? Let's kind of scroll down. We're going to have x squared minus 8/5 x, and then plus 16/25. This equals 21/5 plus 16/25. This left side is a perfect square trinomial. The right side is just going to be a constant. I just need to multiply this by 5/5, so I have a common denominator, and then I can figure out what this side is going to be. So 21 times 5 is 105. If we add 105 and 16, we get 121. So this is 121/25. Now, on the left side, again, this is a perfect square trinomial that we've created. So following the pattern from special factoring, I know it's something, in this case you have a minus, so minus something else, that quantity is squared. It's always the square root of this guy, so the square root of x squared is x, and then the square root of this guy, the square root of 16/25, well, we know if we take the square root of 16/25, we get 4/5. So 4/5 goes there. So we've got x minus 4/5, that quantity squared, is equal to 121/25. And then now I could take the square root of each side. So I'll take the square root of this side, and then plus or minus the square root of this side. So we'll have x minus 4/5 is equal to, you've got the principal square root of 121/25, which is 11/5. And you'll say, or you've got x minus 4/5 is equal to the negative square root of 121/25. So that's negative 11/5. All right, so now let's solve these two equations. If we add 4/5 to each side over here, what are we going to have? You'll have x is equal to 11 plus 4 over that common denominator of 5. So you'll say x is equal to 15/5, which is 3. Then over here, you'll have 4/5 added to each side of the equation. So we'll have x is equal to negative 11 plus 4 over the common denominator of 5. Negative 11 plus 4 is negative 7. Negative 7/5 is negative 7/5. So x equals 3, or x is equal to negative 7/5. So in solution set notation, we'll go ahead and say this is negative 7/5, comma 3. And again, if you want to check these, go back and plug negative 7/5 in for x in the original equation. Verify the left and the right side are equal. Then plug 3 into the original equation for x. Verify the left and the right side are equal.